All right, let's get started. Welcome to the June 2022 OpenZFS leadership meeting. I think we have one item on the agenda, update from Brian Atkinson on DirectIO. Any other items that folks want to add to the agenda now?
Yeah, I have some ideas on how to have the interface for having multiple user keys for encryption.
Awesome. All right, let me add that to the agenda. Somebody is adding it. And I saw also some added DirectIO taskq scaling. Any other items folks want to add now? All right, then why don't we get started with Brian's update on DirectIO?
Hey, so the last I think probably anybody's been updated on this was the developer summit. And good news, I think that the Linux side is completed now. And first and foremost, I'm here to solicit reviews on the pull request. There was a couple.
I'm not hearing Brian. Oh, it looks like Alan is still moving.
Yeah.
Wait, can you hear me?
Brian's back.
There we go. All right, you're back.
Sorry. Apparently my internet connection is unstable at the moment. But I don't know what the last thing you guys heard, but there was one part we had talked about where doing stable pages, and that was the concept of, say we've taken a user's buffer, we've or pinned it in, using the kernel, and we're going to directly write it out. Well, they could still change the contents of that buffer. Unfortunately, after going down many kernel rabbit holes, it doesn't seem you can actually do that through the kernel. The main trouble comes in with the user's pages possibly being anonymous pages, which is commonly what they would be. So it just means like the pages aren't backed by a file or anything. So like if they malloc, fill them up and send them, there's no way in the kernel to protect the page table entry of anonymous page. At least no way I could figure out how to do. So that's very unfortunate. So what I wound up doing instead is I added a module parameter, specifically just DirectIO direct write verify. And what it does, if this is enabled, it's another stage in the DirectIO pipeline. So right before it goes to say, okay, let's update the block pointer in the done function because we've successfully committed this out. If you get a checksum failure there, it's like, no, don't do that. This has failed. And what I wind up doing is sending a Z event or Z, so it can be seen that way. And I also added a Z pull status, lowercase d, and you can see these checksum verify failures that happen there. But it's never committed to disk in that case. It's just like, no, something changed. And so we're not going to do this anymore. So it just bails out and returns EN val in that case. The good thing is that does work on FreeBSD though. The stable pages do work. So unfortunately with Linux, we're kind of stuck.
So the semantic that you would be implementing is basically like your application is required to not modify this while the write is in progress.
Right.
But we have this safety that's going to double check it and fail the write.
Exactly.
The alternative would be to not require that they abstain from writing or abstain from storing to that memory while the write is in progress. And the only way to do that would be to copy the data somewhere else.
Exactly. Yeah. So I mean, it's at least a safety net in there. And again, the cool thing is, I know one concern we had is, if a user does unintentionally manipulates it and it writes it out, there was the idea, well, you have a checksum failure. You go to read it, it's like, hey, something's all wrong here. And there's no real way to coordinate that back to what caused this. Is it, an actual hardware thing going on? But at least with this module parameter and the zpool status now, it can be like, no, this is exactly what happened. We didn't commit that right. So Like, please don't manipulate your buffer, you know?
And would the check be on by default?
I have it off for now. Cause I kind of view that as like,
Well, you're doing like an extra checksum on every write if when it's
Right.
on, right?
yeah, so I mean, it's costly. I, I would like to have it as a thing where it's like you opt into it. But I mean, I'm up for people telling me that no, default's on, and if you're feeling comfortable enough, don't do that.
Can we tell at that point in the ZIO pipeline if it was a DirectIO write? And
Yes.
only do it in that case?
Yes, and
Okay.
that's all I do. Yeah,
Right.
it's because I do the DME write policy. I flag it. It's like this is DirectIO right here. So that's the only time it happens.
What's the ramification to the pool in the event of these write failures?
Nothing in
Like
the sense. Oh, sorry.
Like
Go ahead.
they're just kind of ignored. So like we get write errors, then everything just continues driving on, and
Yes. Yep.
Hmm.
Yeah, and then there's cleanup done as well, just through the normal ZIO done, right? So if we set it, it's eval. It's like, all right, clean up the metaslab. It's as though the write never happened. At least that's how it should work. I'm pretty sure. When I've told, but again, this is where reviews come in, make sure I didn't mess that part up. But everything I've tested and looked at, it's like, all right, we seem to clean up correctly. We were just turning eval at that state.
so consumers in that case unless they're watching for these checksum errors, wouldn't realize that their writes didn't actually happen.
They would get
would
an
detect-
eval.
Oh, so the eval goes all the way back up.
Mhm.
So all this is done synchronously at the time the write is happening. There's never it's never an async path.
Right, exactly.
Okay.
Yep. Then again, they also added the Z event, like it's there as well. I put a test case in there as well to test this out for Linux, as well as the FreeBSD side. Again, the good news, we can write protected FreeBSD, no problem. So I've added a test case for that. That seems to be working fine. And the only other thing that's kind of lingering at this point, there is this one FreeBSD error, which I'm also soliciting help for that here as well. For some reason, just with reads, the first, like if you're doing multiple DirectIO reads, requests one after another, the first one, for some reason, when it goes to fault hold the pages, seems to fail quite often. And I have no idea why. There's just a failure that returns up from the VM fault quick hold pages from FreeBSD. And in that case, because it's like the Linux compatibility FreeBSD code, they return efault, which is what I do in that case, and it percolates back up to the VFS layer, and then it sends it back down, but it's two separate reads of smaller chunk sizes. So it's super strange. I don't know why that's happening. But I do have a separate branch that I can point FreeBSD people to with the test case that also dumps D message like, hey, here's some printfs that shows exactly where we're failing. You know, while it works, it's not working correctly. So any help there would be great, because I think that's really the one lingering issue at this point, other than people commenting on the pull request, trying it, possibly breaking it.
So for the verification thing, is it faster to do this double checksum versus copying the data?
The
That's
performance
the same
hit,
thing
the performance hit is what kills you.
on the B copy or
Yeah,
the
which
checksum.
one?
The copy.
So the copy is much slower.
Yeah, is worse than the checksum calculation.
Interesting.
Which is the whole reason we started doing the O direct, you know, it was the memory copies that were killing us.
Yeah.
Is it still worse if you have one of the stronger checksums on? Or is that just true for, say, Fletcher 4?
I mean, it may, yeah, I mean, I haven't run a whole sweep of like, what's the cost penalty associated?
Is the can the copy be like opportunistic? Like, can you detect at the time that somebody's actually making the second modification and only do the bcopy then?
You'd have to be able to detect that.
Yeah.
Yeah,
which
that's
would
what I'm
probably
wondering. Like,
checksum.
like,
Like
can you
using,
detect that?
yeah, like, I mean, I wonder, rather than, so I guess I have two questions. One is around what should the default behavior be? And the other is, if they do not, if we are verifying by default, then is the right behavior really to give them EIO or eval, or is it to just like do the bcopy then? Like you do the checksum, you do the second checksum and it fails, and then you say, oh, checksum failed. So now I'm gonna bcopy your data and then write it out.
Well,
And
the
then write
problem,
out that.
Then you have to send it back through the
stable.
pipeline though.
Yeah, yeah.
Yeah.
I mean, I'm sure that's like more complicated to implement, but
I guess one of the questions is which is the right data to write, the original version or the version
Either
they
one.
just modified again?
either version is
You had-
correct.
I guess
to
the
write.
old one we
yeah.
probably don't have anymore if they overwrote it though.
Yeah,
Yeah.
either
can't-
version is correct to write. It's just that the checksum has to match it.
Right. Right. So you're saying that when we get the checksum failure, should we reset the pipeline and write out that new version with that correct checksum rather than erroring out?
Yeah, yeah. I mean, or you could like instead of copying it, you could just retry loop, right? Just be like, well, I'll retry again until I get two checksums the same. But I mean, obviously that could infinite loop.
Yeah.
Seems
Yeah.
not great.
And there's still no, even after you do the checksum verify, say it passes, they can still go in there.
Yeah, I mean,
Well,
they could
hold
be
on, yeah,
like if
ish.
you're just like twiddling, like flipping some bit on and off,
Yeah.
like you could have the same checksum before and after, but in the middle it had some other value that is not the value that was checksum. So, I mean, maybe given that, you know, maybe it doesn't make, maybe the E in val does make sense because, you know, we can't guarantee correctness in the face of concurrent stores. We can just try to detect some, you know, modifications, and you know, maybe what you, so given that, you know, maybe what you do is you say, for the question of should it be on or off by default, maybe it's not on or off by default. Maybe this is probabilistic, and you say the default is we're going to check 1% of all of your writes, or you know, some percent. So we're going to double check some, you know, 1% of your writes, and then let you know if you're doing the wrong thing, right? The requirement still continues to be like, you have to not modify it, but we're just going to give you like a little bit of a double check so that, you know, you're not if you get a checksum error later on and you see that the counter was bumped, then you know that like the application probably is doing bad things. And if the counter is not bumped, you don't really know for sure either way. But even if we double check something every time, we couldn't really guarantee that either way if the count is 0.
So you're saying possibly just periodic, hey, let's try the check real fast.
Yeah,
Hmm.
because that
Then
way,
it doesn't have the cost of being on all the time, but
yeah,
you don't have the advantage of, if we have it off by default, no one will ever turn it on.
yeah, like you have the performance. The performance would be probably negligible. Performance impact of doing it 1% of the time would probably be negligible. And that way you have at least some chance that people who are just using it like naive, the concern is naive users, right? Like naive users are like, oh great, like direct, let's direct it, that'll make things
Right.
go faster, right? Like
Yeah.
everybody on the internet says use direct to make things go fast. They don't know what they're talking about. They don't know, they may not even know that you're using ZFS or whatever, but like I read some advice on the internet that says direct means go fast, so
Mhm.
I'm going to use direct. And then you know, a month later, oh, ZFS is just full of checksum errors, my disks are fine, this is all broken.
Yeah.
Right. And so we want to like have some kind of safeguard for those naive users, which is why I think having some kind of verification, maybe not 100% of the time, like double checksum, maybe it's 1%, maybe it's 10%, like I don't know, some kind of verification for those naive cases, so that at least then, like if we get inundated with like, ZFS has unexplained checksum errors, we can be like, hey, check this count. Oh, the count of, you know, wrong double checksums is non-zero. You're using ODirect wrong. So
Yeah.
you know,
Yeah, and I do percolate that counter up to the top level VDEV as well. So it's not like per, I mean, I don't know. Yeah, I felt more intuitive to me, like top level counter, but
yeah,
yeah, I guess the heuristic for determining that percentage, I think we'd have to think on.
yeah. I think you would probably just like set it as high as possible to value this as high as possible while not impacting performance,
Yeah,
you know, measurably.
okay.
I mean, think of it like for every 100 writes, you're doing 100 checksums plus a lot of other stuff.
Yeah,
So we're saying like if for every 100 writes, you're doing 101 checksums plus a lot of other stuff, you know, the same amount of other stuff, you know, the performance impact is no more than 1%.
right.
The question is like, how much absolute overhead do you add with the checksum? Because like if you look at it in a latency histogram, then say a 50-50 split, and we'll have one peak at the latency without doing the extra checksum and one peak with the other one. So if you're doing something latency critical, you're going to end up with like always assuming that you're checksumming, right? So on average, Matt, you're right. But if you care about like P90, whatever latency, then yeah.
Yeah, if you care about like P99 or P99.9, it could matter. I agree that is true. I hope and assert that it is not important. But if people know that it is important, then definitely contradict me.
They can promise to use DirectIO write and set it to 0%.
Yeah, sure. I mean, look, if you're well informed, then you can change the value to whatever. Then you know you're informed enough to change this tunable to whatever you want.
So we still keep the tunable, but that's the adjustable, I guess, scale then, right? Is like every so often we're gonna double check on this count. Okay.
Can we make it so individual application threads can opt in, or do we lose the context? I guess we lose the context deep in the CIO pipeline, right? We don't know which thread issued the call.
I mean, you probably could do it on a per dataset basis or something. I think it would probably be fine to just have a system-wide tunable.
Okay.
Since, you know, we're still like, the tunable doesn't control any kind of correctness, behavior, what the expected interface is. It's just like, you're always required to not do stores on direct, like while you have a DirectIO write in progress. And we're just doing a little double check for you. If you get it wrong, then what's going to happen is that like the write will succeed. And when you go to read it, you'll get a checksum error. So like you told us to write this data, but you can't actually read it back. So, you know, we're just trying to help you we're trying to help you know when you might be in that circumstance so that you can know what to fix, right? When you're like, oh, I got a lot of checksum errors, then you know, oh, what I need to fix is not my disks, but rather my application or my use of ODirect.
Okay, yeah, I think it makes sense to change it to a count parameter then.
Yeah. So I guess I'd just add that I think most of the applications on Linux already have this expectation, right? Where they know they shouldn't touch something that's doing DirectIO, right, while it's in flight. This is like not
Because
a
then
new
your
thing for
results are
any of the existing
non-deterministic.
file systems, right?
Yeah.
Right.
Like your results would be non-deterministic if you're modifying it while you're writing it out, right? So
yeah, and I think most of the main consumers of this interface that like already exist, right, the big ones, already know this and do things right. So I guess we're mainly worried about someone writing a new code or turning this on.
Cases where they're just like, oh, direct means go fast, and I want to go fast, so I turn it on.
Yeah.
And I don't really know anything about the application. I'm just like, sysadmin, and I have a bunch of random applications.
Does anybody know what kind of like the behavior is for other file systems on Linux if you use ODirect and concurrent consumers?
Well, typically there's not a checksum associated, so it is what it is, right? The data hits disk, just kind of
So
is
we
what
could-
it is.
We could
Well, then
just
I'm wondering, like,
checksums off, and then we'd be doing as well as they are.
yeah, exactly. Like,
Exactly.
Is there, so in other words, is there a value in us like telling them that they're doing it wrong when the typical, consumer of other file systems effectively would never know they're doing it wrong, other than they just get like busted data?
Yeah, I mean, you could argue like, hey, you want to do ODirect? We're going to turn your checksums off.
Yeah.
I'm not sure that's a great idea, but I think that there's an argument for it.
The problem is ultimately that we don't attach to the block on disk or the block pointer that points to the block whether the block has been written by ODirect or not. If we had that bit of information, then we could like surface the checksum errors in the correct way, differentiate between all that. I don't want to argue changing on disk format though, but I think that is the crux of the problem.
I think we did talk about that at one point. This seems like an easier.
But yeah,
way.
even at that point though, like if you know it was a DirectIO write and you get back data with the wrong checksum, you still don't know if that was because they modified it after you generated the checksum or because the disk actually mangled
That
it
is
on
true.
you.
That is true. Yeah.
It's a hint that, you could tell the user
Could have
this might
been.
be because of that, but that's about it.
Yeah.
And if we wanted to do that, I suppose the way we could do that was the per dataset feature flag activation thing, like we did for Z standard, where we flag a data set as soon as any block's ever been born that use DirectIO for write, and we be like, if you get a checksum error here, maybe it means something, but I don't know if that makes sense.
In my opinion, I think it'll be sufficient to do the, because like we're saying, applications, they wouldn't have deterministic behavior if they were doing this thing, if they were doing the concurrent modification today. So like they are very likely to not be doing that. And so, we can just kind of assume that that is fine, but we're, like in ZFS, we try to go above and beyond. We have checksums. We assume that you have the checksums on. And so, part of that doing better than other file systems is like, we're gonna check and make sure and record if you have this double modification. You could also argue like, maybe in the double modification case, like, well, I mean, I guess getting the error back to the application would give you a good clue. Like it would make sure the application dies sooner rather than later, and then surfaces the error rather than just having rather than just like recording it on disk. So yeah, I like what you've done there. I had another thought, but now it's lost me. But I think that this is this approach seems good and like better than what other file systems are doing. Oh, the other thing I was going to mention, if we wanted to go even further, another thing that we could do to help folks would be to have a tunable that's like, don't verify checksums on read. And so that would let you, like, if you ran your application and it did these writes and it did the concurrent modifications, and now you're like, oh, I'm getting checksum errors. My data isn't there. I'm so sad. We could say, well, you can set this tunable to just say like, ignore the checksum error and give you the data that is inconsistent, which is just as good as what other file systems are doing.
I have about
Um,
90% of
work
that
with
done as
server.
a patch for ZDB, specifically to extending my hackathon project to be like, I have this file, it has checksum errors, extract the whatever is
The raw
there
data.
anyway.
Yeah. I mean, you
Yeah,
could do
so
that.
throwing in the, so there is actually like a practical concern. For example, if you use ZFS send receive somewhere, I think if we encounter a checksum error during ZFS send, we stop the send, right? I don't know whether there is a flag to tell it to send corrupted data.
There
I
is.
think there is. Yeah, yeah.
It
It doesn't
replaces the
send the
data with
corrupted
a
data
known.
though, yeah.
It replaces the data with a pattern.
Yeah.
Anyways, I think that's kind of not required, but might be something nice. If this is even at all like relevant. I mean, hopefully none of this is relevant, and we're just like going the extra mile that is not really required. But I think especially given that you've already implemented this, the like double checksum checking and all that stuff, keeping it in and having it on, 1% or a few percent of the time would be nice.
Okay, yeah, and it seems like the count, I mean, makes sense, and we can set a default of, I don't know, 100 or something.
Yeah.
And just, I mean, I'll have to go back and update the code, obviously, to increase the counter, but that's not hard. Change the module parameter naming just to make sure it makes sense. Yeah, so the only other thing that could, I would bring this up here while I'm thinking about it, that can trip you up in this case, like, okay, the user is adjusting the buffer out from under you. It's so like in the compression path, and I'm sure this happens in other places too, but for sure on compression path, like if you have, debug on and the data has been manipulated after the compression has taken place, then the ABD compare will panic on you because it's like, well, that's not what I just, created a compression on. But that's just, you got debugging code on at that point. And if we wanted, I could just, add another parameter to it. The ABD call, just be like, this is a DirectIO write. Don't sit there and do that during debug, or we can just be like, well, again, I don't know anybody that's running debug code on production anyways. I could be wrong. I could catch a developer if that were to occur, but again, I don't know why they would be manipulating it.
But I guess again, that's pointing out that they're doing it wrong.
Yeah,
And so it's probably a good thing rather than a bad thing.
yeah.
Yeah, although it's not our bug, so we probably shouldn't be panicking.
And again, it's if we wanted to adjust it, it could simply just pass in another parameter, the ABD call.
Yeah.
I
I mean, if you're using compression, like you're already paying, like that's a pretty big cost, and you're already kind of copying the data around.
Yeah, and that's just it. That's just it.
compression.
Once it's compressed, right? It's that ABD compares to the original buffer when it turns it back. It's like, hey, that doesn't match. It's just
But-
debugging code.
Like, does it make sense to do zero copy DirectIO writes if you're doing compression at all? Like maybe if you have compression on, we can just copy your data first and then compress it. My concern is like, if you're concurrently modifying it, what if you're like, are we sure that the compression, like, do all compression algorithms access each byte of the input buffer exactly once? If not, then presumably if the buffer is changing out from under the compression algorithm, then the output results are completely garbage, right? And so like in that case, you might have something where it's like, yeah, like I did the compression, it output garbage, then I did the checksum. I'm checksumming the compressed data, which is like obviously correct. Like the checksum will match. I write it out, I read it back in, I'm like, great, like I checksum is correct. But then when I go to decompress it, the decompressor is like, this input is garbage, and explodes, which looks very much like a ZFS bug. That seems kind of concerning to me.
When it But I'm confused when it decompresses, it would blow up how though? Because I mean, the checksum's still valid, right?
Oh yeah, the checksum is valid and correct, but the
Yeah.
input is garbage because the compression code, like the compression code probably assumes that the input buffer isn't changing while it's doing the compression. And if it is changing, then probably all bets are off as to its output. Right? Like you could imagine a compression thing where it's like, you know, it's building some table that's like, oh, I noticed this string at this offset. And then later on,
Right.
I'm like,
Yeah.
you know, is the string at the current offset the same as the string at this
I
earlier
get what you're
offset?
saying, yeah.
And it has like a pointer into the earlier data, right? And so like it might make the wrong decision about whether this data is the same as that data, because it's like that data has changed between when I first looked at it and when I'm looking at it now.
Yeah.
And I mean, maybe the output would be like decompressible, but just give you the wrong results.
Right, yeah.
And the checksum would be right, and you'd be like, great, like checksum correctly. Here are the results. Here's your data back, and it's just like it's neither the it is no version of the correct data. It's not like we got your data as of some point in time. It's just like completely mangled because the compression decompression like, you know, lost its brain.
Wouldn't the checksum still fail then because it checksum before it applied the compression?
No, the checksum is the on
it's
disk
after.
version.
Oh,
The
okay.
checksum is applied after the compression.
That's right.
Yeah.
Sorry, I remember this now.
Yeah,
And I
it's
think
kind of
on
unfortunate
like
for this use.
on the compression, because we create another buffer, I think we've already copied the data and we do like a push transform and then that gets popped off later.
But
So like
we compress from the input buffer into a new buffer, I think.
Yes,
I think
but I
that's
think
the case.
George
if
is
it-
also right. Sometimes we create a new linear buffer because the
Yeah.
compressor can't consume an
Oh.
ABD. So sometimes we
Yes, there's
copy the data first, then compress it into another buffer.
Yeah,
I believe we
so-
do that all the time, actually.
I don't think
Okay.
any of the compressors support reading ABDs yet, no. So yeah,
all right,
but
so if we make sure that we do that, so yeah, like let's copy the data before doing the compression. Sounds like we're already doing that in some
Yeah,
some
we are.
cases. So
Yeah,
just
the
make sure
think
we do
all-
that in all cases.
Yeah, it's ABD borrow buff copy. So like what I was saying is when you do the ABD return buff, that's just so the debug gets you there, right? Because it's like if the contents have changed, it's like
But so
that
what I'm
doesn't
saying,
match.
but what I'm saying is like ABD borrow buff copy does not always copy the data into another buffer, right?
right, it doesn't if the original buffer is already linear.
Linear, yeah.
Exactly. So
Well, but
I'm
wait,
saying,
for
like,
DirectIO, we're never linear at this stage.
what if it's a scatter with exactly one entry?
It's a linear page. We do. Ryan, help me remember this. I can go look at the code and try to remember, but I think what we do is just a linear page. It's still a scatter.
Yeah, that's
ABD,
my
though.
recollection too, because we still treat it as a scatter, a special kind of
Yeah.
scatter, which is one page and map it. So
And map it and then copy it?
I don't think we copy it. I think we try to be clever and don't. So
Yeah,
we might
so-
need to make sure we make a copy there.
Yeah. So I think that we should just change that to say, you know, we always make the copy. And maybe the way to do that is like in this code path, rather than using ABD borrow buff copy, you use like the ABD iterate function and do the copy ourselves. So it's like, we definitely know that a copy was made because like we allocated the buffer, we
Yeah.
iterated the ABD, we copied the data into the buffer, and now it's stable data that we're passing to the compressor.
I guess do we know how
You know-
big of a performance hit that would be, say, if it were a linear buffer to begin with, though?
well, we only need to do this if it's not, we only need to do this if it's a user data buffer, right? Like
Right.
you only do this.
So you're
if
saying, I get what
the
you're saying.
ABD
Yeah.
yeah, if the ABD is pointing to the user's address space, then you do this. Otherwise,
Which
simply
we flag. Yeah, we flag, so we could do that. Okay. Yeah, I can go in there and adjust that code.
or maybe, I mean, maybe you could even do, this could be part of ABD borrow buff copy, is like, if the ABD knows that it's user data, then it's like, oh, if you're doing borrow buff copy, then, and it's pointing to user data, then we're definitely allocating a new thing and copying
Right.
it for you.
Yeah, absolutely. Okay, yeah. Okay, yeah, but still, I mean, and I'm glad we talked about all that. That was good. But the return buff still could trigger
How so?
But that's the
because the source is still changed out from under you. And I remember, like in that debug code there, all it's doing is like, does the source returning the
yeah.
buffer? Did they match?
Yeah, I
Yeah,
would,
not a big
free.
deal.
I would just, I would change that to not make that assertion if it's,
Yeah,
if the ABD is pointing to user data.
yeah,
Right, like, I don't think that we want to, I mean, it is a corner case, it is a debug thing, but I still would rather not make ZFS panic because applications misused it.
right.
Yeah. I agree. Even with a debug build, there shouldn't be anything an application can do to cause it to panic.
Yeah, I mean, users should be able to know, like, if the system panics in ZFS, I can file a ZFS bug because there's a problem with ZFS.
Mm-hmm. Okay. So yeah, I think that was the only major things I had with it. And obviously, like, you know, in reviews, people look at it and taking it for a test drive. I mean, again, I feel pretty good about the Linux side. Making these modifications makes 100% sense. And yeah, if we could just get anybody to look at that one lingering error. And again, I have a branch, my own branch I can point them to. It's like, hey, run this. There's the message output. At least to show where the failure is starting to occur.
Yeah, this is great. Thanks a lot for your work on this. I know it's been a long time coming.
Yeah. Sorry it took so long.
Oh, that's all right. Yeah, thanks for bringing up these issues here. I think, I mean, hopefully none of this really matters because applications aren't doing it, but I definitely feel better knowing that, you know, ZFS is kind of doing as best as we can with these kind of tricky semantics.
Yeah, absolutely.
All right, next agenda items. ZIO taskq scaling from multiple pools.
Yeah, that was mine. So we have a tunable ZIO taskq batch percent, defaults to 75% and defines how many threads we do the ZIO processing on, which is the bulk of that is compression and checksums and things of that nature. So it defaults to 75% of your CPU cores. The idea being to leave some system time left over so that if you're writing to a highly compressed data set or something that, you know, your system's not going to not be responsive because all the threads are busy doing compression. The problem is we create that many task queues for each pool. So if you had two pools and you say we're ZFS sending from one and receiving to the other, you'd be using 150% of your CPU cores for decompression and compression. If you were, you know, I think the user was reading from a pool that was gzip compressed and writing to one that was zstandard compressed. Or, you know, another example is, you know, somebody has 7 pools, then that's a lot more threads than they actually have CPUs.
Yeah. Did you have a solution proposed for this?
I was curious what other people thought the right thing to do there. Like with the dynamic mode that we have, we could try to, you know, lower the number of threads per pool when you add more pools, but you know, sometimes people have some pools that aren't busy and some that are, and then how do you make any of this make sense in the case where you know, I have 2 really busy pools and then I have my boot pool, and I don't, do I want the same settings for all of those, and how does that work?
I don't really know. George might have thoughts about this, but would it make any sense for those task queues to be global rather than per pool, or is that just inviting deadlocks galore?
I mean, that seems like the reasonable approach, but then like, you know, like I wonder with things like, you know, like when you have our pool and then a really busy pool, like, could you get into like that deadlock scenario where like the real busy pool just is like starving out our pool?
Yeah,
at
I would
times?
worry
I
about
don't- I-
dependencies. Like what if you have I mean, if you have a pool that's based on another pool, you know, we're not real, like
Yeah.
that's not like super supported, but that seems like it could be problematic. And
Well,
then
even just if one of the pools is hard drive based and has high latency, and the other is NVMe based and has really low latency, do you
maybe
end up?
starve. I mean, I don't think that I doubt that there's a real starvation issue because the task queues are FIFO.
Mhm.
Like, I mean, you know, they're work stealing and whatnot, but like more or less, it's like more or less FIFO. So I would think that the fairness would be reasonable. My concern is if like there's dependencies, because like right now, you know, you can't have dependencies from one, what is it like, within one ZIO type, like say reads, you can't have a read that depends on another read. You can have a read that depends on a write, or a write that depends on a read, because those are different task queue groups. But my concern would be like if you have multiple pools and you're doing like say this like send and receive from one pool to another, is it possible that you introduce a dependency that's not allowed, where it's like, you know, I'm doing a ZFS send, so I'm doing a read. I mean, I guess you shouldn't, right? Like you shouldn't need to, because at the ZIO level, there is no interaction between the pools, unless you have a pool based on another pool. Then you're probably out of luck.
I guess the other question is, inside the task queue, does it have the information about which pool it's for, or does it avoid that because it knows the whole task queue is for one pool? Like, do we have to grow every data structure to attach a bunch more information to it in that case, if we share a task queue between all the pools?
I don't think you need to attach any more info.
I think the problem you may encounter is that now, like some of these task queue locks, which are already really hot, get really, really, really hot. So Alan, when you kind of like, is this something you kind of encountered in practice, or?
Yes. So
Okay.
in 2 different cases. The one case was just a user doing a send and receive from one pool to another, and the system was basically becoming almost unresponsive because they're using 150% of the CPU cores for compression and decompression, because 2 pools each using 75%. And the other case was just a customer that has 7 separate busy pools, and noticing, you know, they're starving each other for CPU time, or just overall, we're creating, you know, they have 112 CPU cores and they're creating task queues for 75% of them times 7 pools. And it's just a lot of extra moving bits. But because that is a tunable you can only set before you import any pools, it gets hairy to, you know, try to adjust it as you import more pools and so on.
Yeah, and for like a customer like that, I mean, did you get a sense for what they would like to see? Like, would they want to see all the pools like reduced the number of like write threads? Or are they wanting something like, oh, I have these 3 pools that are more critical, so I really want them to have more CPU than the other, you know, 4 pools?
In the 7 pool case, they're all the pools are of equal importance to them, but I can definitely see that being for other people. Yeah, I was almost thinking like, should we have a Z pool property that controls this? And then if it's not set, we default back to the system-wide tunable or something? And does that make sense or does that not make sense? And, you know, that helps maybe with the R pool case where it's like my R pool only needs, you know, X threads or whatever, but all my other pools need, you know, 25% of my cores or whatever.
The problem we have so many different types of I/O that you would have too many knobs to tune. That's probably not.
Well, yeah, that's this is just the ZIO batch task queue. That's not even mentioning the, you know, we got what the read normal and read high priority issue and interrupt, and then all those for write, null, IOCTL, etc. Yeah.
I mean, I think that there's not an obvious solution here. If you might try making it a system-wide task queue rather than per pool and like see if that seems to work.
Yes, the other option is making that tunable more dynamic so you can change it at runtime and just lowering the, you know, when it's the dynamic task queue code goes to be like, you know, should I spawn more? If you're like, actually, I'm over my quota, I should shut down task queues as they become idle or before I dispatch more work to them. Yeah.
Feels like a great hackathon type project to go even for like either of those options, right? Like to go as a global ZIO task queue or a global task queue implementation, and then one that like allows you to adjust.
Cool. Let's go to the next topics just so we can try to give like 5 minutes for each of these other 2 topics. The next one, multiple user keys for encryption.
Yep. So I was looking at basically the user-facing documentation and whatnot. And it looks like the cleanest way to do this from the user's perspective would be to use the @ notation on the properties and have multiple slots. So you'd have like key format @0, @1, etc. for slot 0, slot 1 for different user keys. And obviously all that would be stored in the metadata, and we'd just wrap the encryption key multiple different times, which is similar to what we're doing now, just do it more times. And then you'd add a command for ZFS add key, which would allow you to add an additional key, ZFS remove key that would prompt for a key that would then find the slot that is using that key and remove it, or remove slot, which would then just clear that slot, is the high level of that. It's largely modeled off of what Luke's is already doing with their multiple key slots. I believe they offer 8 key slots. I was going to go with that until I saw a technical reason otherwise. But that's the high level view of that. I can show what I edited in the man page if you want me to.
That sounds reasonable, I think. Yeah, if you want to get feedback kind of before it's ready for code review, you could maybe open an issue or push the mailing list with the man page changes.
Cool. That's pretty much what I've got.
Any questions or comments on that? All right, then the last one is 11679. I'm not sure whose was this.
That would be me. That's the bug where if you do receive an encrypted send, it panics in a null dereference. I have 2 solutions that are implemented in work, and I was wondering if I could get opinions on which of them is less gross. But basically the bug is that there's a special code path for in-place decryption of dnodes in the ARC read code. And what can happen is that you can have an arc write that happens and dumps out the buffers while it's going through arc read. Well, it's debuff write, which calls arc write, but anyway. And so you can be trying to do a read on one of the buffers while somebody has temporarily set it to null, and your life is very sad. I have two different solutions for this.
Which data structure is being concurrently modified where somebody might set it to null while you're trying to work on it?
Specifically, what happens is that the PABD and RABD in arcbuff header get set to null temporarily while going through the path of arc write ready, arc write done, and they don't really check much before they do that. They just set it. So like it sets it to null in, I think, ready or so, and then change and fixes it in done. And
I don't know what the locking is supposed to be like there, but should it be holding the arc hash lock on that entry doing that so that
you would think that would work? It does not work.
Okay.
But I tried that and it does not help. The two solutions that I have at the moment are that I have something that refactors the arc write code path so it doesn't temporarily set it to null. It's somewhat invasive, but it works. The one I think I prefer is that the thing that does the decryption in place doesn't really actually need to reference that buffer. So I just added handling that notices if the buffer is null, and if it is, it just goes and takes, it just allocates a temporary buffer. I could do that unconditionally, but sticking an unconditional allocation in didn't necessarily seem like the best performance choice.
The code path where we're unencrypting directly into the buffer, is that the case?
Specifically, what happens is that we try to decrypt directly into the buffer. Yes, that's what that code path is specifically for.
And that's happening in the context of a receive?
The bug only happens in the context of a receive.
Because I mean, like, what I'm thinking about is like, if the header is already in write, then how is it discoverable? Like it should be an anonymous header, right? And we would have released it as part of the write.
I can go into detail on how this happens, but basically, if you trigger the quota recalculation code that goes and dirties everything, there's a window where this can happen. I don't have a good explanation for why, honestly, but
I mean, I think that's probably why there's no locking in place, because the assumption is that you shouldn't be able to like find this buffer.
In theory.
Yeah, in theory. That's interesting.
I would prefer a better solution than this, but I will take not panicking as a starter.
I mean, I would be interested in kind of like the details of like.
I have a write-up.
Kind of
I can link that.
And then maybe I can provide some better alternatives, but yeah, I'd like to kind of understand the scenario first. But I'm cool with what you know, if you're doing like a temporary copy, if that's a solution, you know, to keep it from panicking, maybe that's what we need.
The silliest thing is that it doesn't even need to copy really. Well, anyway.
It just needs it to be not null.
Yes. It needs a buffer that is not null somewhere.
Yeah. Yeah, feel free to send me like your write up or point me at it.
I just linked it in the notes. It's not everything, but it's most of it.
Okay, cool.
But well, it mostly summarizes what I just said, not in much detail. I have a lot of experimenting and things that do and don't work. Mostly don't. But
cool. It sounds like we need to dig into this a little bit more, at least to understand. Thanks, George, for volunteering to take a look at this with Rich.
Yeah.
I think we're almost at the end of the meeting time. I wanted to just mention that we're still working on planning the OpenZFS conference. We're looking at dates. It looks like it might be in early November. We're still trying to plan an in-person conference, as folks have indicated from the last meeting. We're still, the opportunities are still available to help out. If anybody can help with the planning and logistics, that would definitely be appreciated. We're kind of going forward with the resources that we have and trying to do the best we can with getting the venue nailed down, and then we'll work on catering and stuff. So looking forward to seeing you all in the fall, and hoping that COVID will be calm then. In the meantime, the next meeting will be in 4 weeks, which is July 19th. Delphix folks have a company event during that time, so I think we might not be, some folks might not be able to attend then. Brian Bellendorf, would you be available to lead the meeting on that time on the 19th?
Yeah, that should work for me.
All right, cool. Thanks. Great. Well, thanks everyone, and goodbye from sunny San Francisco, where it's reached 95 degrees on the solstice today, which is why I'm on a different camera, because my camera overheated. So I had to fall back to the MacBook camera. So have a great, enjoy your summer, and we'll see you again in 4 weeks.
Yeah.
Thank you.
Yeah.